Saturday afternoon class. That is not good. Right. Om Sri Guru Basvalingaya Namaha. So, last class we covered oxo acids of halogens. In oxo acids of halogens, total 4 kinds. In them, we covered one is HXO type, then HXO2 type, HXO3, HXO4. Total 4 oxo acids. In them, here oxidation number of halogen atom is +1, here +3, +5, +7. These 4 oxy acids of halogens are possible, and it will be hypohamous acid, hypohamous acid, it is a hamous acid, hamic acid, then perhamic acid, can also known as hamic 1 acid, hamic 3 acid, hamic 5 acid, hamic 7 acid. So, these are, suppose if you go fluorine, chlorine, bromine, iodine. With the fluorine, HFO possibly is there under ice cold condition. With ice water, fluorine reacts to HFO. Then here HClO, HBrO, HIO, that is hypofluorous acid, hypochlorous acid, hypobromous acid and hypoiodous acid. Whereas here hamous, that is fluorous acid, fluoric acid and perfluoric acid not possible. Fluorine could not able to form these 3 kinds, only HFO, that too with ice cold water. Clear? At normal condition, fluorine reacts with water, convert as HF with the liberation of oxygen. Suppose 3 moles of water coming together, O3, ozone is able to form. That's the reason why under normal condition fluorine could not give these. This is also with ice water only HFO possibility is there. And chlorine HClO2, even HClO3, HClO4. In NCERT, in tabular form, HClO3, HClO4 they didn't mention, but chlorine able to form chloric acid as well as perchloric acid. Similarly, it is bromous acid, then bromic acid, perchromic acid, and iodous acid, iodic acid, periodic acid. Clear? So these are possible oxy acids of halogens. Then one after one, just one preparation. If any special property is there, that property let us see here. HFO is able to prepare when ice cold water reacts with the fluorine to give HF with the HFO. Clear? Here H plus go with one of the fluorine as HF, then OH minus from water go with another fluorine atom to give HOF or HFO. Clear? So with ice water only you have to remember. Possibility is there, which among the following, suppose question comes, which among the following could not form oxy acids? Elements they will give fluorine, chlorine, bromine, iodine. In that case, you know chlorine, bromine, iodine perfectly able to form. Thus, fluorine you can take that. But there you should not controverse that fluorine able to form HFO. But their option is not there. If option is there, according to option you have to go. Clear, no? So this is HFO. Then HClO, if you consider, HClO preparation will be when chlorine reacts with water. Similarly, convert into HCl plus HClO. Clear na? Even elementary chlorine with water, mercuric oxide, one more method. Here, elementary chlorine with water in presence of mercury or mercuric oxide will give us HClO with HGO and HgCl2. HGO and HgCl2. Suppose if you multiply it with 2 moles of HGO, now 2 moles of chlorine, balance of 2 to the 4 chlorine atoms, here 2 and 2 mercury, 2 mercury, 2 hydrogens, 2 hydrogens, 3 oxygens totally, 1 plus 2, here 2 plus 1. Right? So here hypochlorous acid can also prepare when chlorine gas reacts with water in presence of mercuric oxide to give hypochlorous acid. Clear? And this hypochlorous acid is anhydride. 2 moles of HClO on dehydrating will give Cl2O plus H2O. Thus Cl2O is acid anhydride of hypochlorous acid. Clear? Here this hypochlorous acid will give us hypochlorite ionization. This hypochlorite on heating undergo disproportionation to give chloride and chlorate. Here ClO minus chlorine is plus 1 to minus 1 and plus 1 to plus 5. Plus 1 to minus 1 addition of 2 electrons, plus 1 to plus 5 removal of 4 electrons. Therefore, here hypochlorite undergo disproportionation to give chloride and chlorite. And here its geometry also if you want, here ClO minus, here around the chlorine one atom only surround oxygen, plus group number of chlorine is 7, oxidation number 1 divided by 2 will be 1 plus 3, total number of pairs of electrons are 4. 1 bond pair and 3 lone pairs. Here total number of pairs around the central atom, if we come to know, compulsory we can decide its hybridization. Hybridization is here 4 pairs, in s orbital 1 pair, p 3 pairs, total 4 pairs. Under sp3 hybridization, therefore sp3 only 1 bond pair with 3 lone pairs. According to Vesper theory we know, here presence of lone pairs cause to deviate original geometry. Therefore its structure will be linear, 1 bond pair with 3 lone pairs. So this information we must know about acid. Similarly, here bromous acid, hypobromous acid and hypoiodous acid. These two also retain the same. Clear? And next that is chlorous acid. Now how this chlorous acid is going to prepare? When barium chloride directly, barium chloride treated with acid, or that barium chloride how will get barium hydroxide when treated with chlorine dioxide. Clear? Barium hydroxide when treated with chlorine dioxide. Here chlorine dioxide 2 moles come forward, that is BaClO2 taken twice with H2O and liberates oxygen. So barium chloride, this barium chloride if readily available when treated with the sulfuric acid, barium chloride reacts with the sulfuric acid to give barium sulfate with 2 moles of HClO2. Like this chlorous acid preparation takes place. Simple. Here the salt of chlorite when treated with an acid. Generalization, the salt of chlorite when treated with an acid will give the respective acid, halogen acid. Clear? So that HClO2 here HClO2 being an acid ionizes and gives H plus and ClO2 minus. Thus ClO2 minus geometry, hybridization and number of bond pair and lone pair. So here around the central atom two atoms are attached. Chlorine atomic this group number 7 and oxidation number 3 divided by 2 will be 2 plus 2. 2 bond pair with 2 lone pair. Total number of pairs of electrons are 4. Thus it also undergo sp3 hybridization. But during sp3 hybridization it will be 2 bond pair with 2 lone pairs. Its geometry, deviated geometry is bent or V. Clear na? V shape or bent or angular. Right? So therefore here Cl double bond O minus. Suppose H, if you consider H is attached to this. Clear na? It is an angular on which 2 lone pairs and these 2 are bond pairs. One more thing also here they may ask here how many number of sigma and pi bonds. Here double bond is having 1 sigma, single bond is sigma, therefore 2 sigma. Suppose H also if you consider here 1 more sigma, 3 sigma with 1 pi bond. Clear? This is chlorous acid. And next consider chloric acid. Chloric acid is HClO3. Chloric acid HClO3 preparation will be whenever BaClO3 taken twice is barium chlorate. Right? Ic acid salt is 8. As acid salt is 8. Clear? So therefore barium chlorate when treated with the concentrated sulfuric acid it gets converted into 2 moles of chloric acid with barium sulfate. Clear? Chloric acid is obtained whenever barium chloride is treated with an acid. I told just now here any salt when treated with the acid to give the respective oxy acid of anion of that salt. Clear? Suppose here ite salt if I take As acid is going to come. Here, this is As. These 3 are As. Whenever BaClO2 are taken twice, or BaBrO2 taken twice, BaIO2 taken twice. Such barium halite, correct? Chloride, bromide, iodide. Barium halite, when treated with acid, will give the respective Halley's acids. Along with that barium salt. Clear no? Similarly, here chloric acid, bromic acid and iodic acid. Salts are what? The respective metallic halate. The respective metallic halate. Suppose HClO3 chloric acid, respective metallic chlorate. HBrO3 metallic salt, metallic bromate and metallic iodate. These 8 salts when treated with acid to give the respective ic acid, that is the chloric acid, right? This chloric acid salts if you consider, this is one of the salt, potassium chlorate we have, familiar potassium chlorate. This potassium chlorate on heating in presence of MnO2, what it will yield? KCl plus 3 by 2 O2. Here one more you have to identify, here only identify and then keep. If it is around 400 to 500 degrees Celsius, in presence of catalyst, liberate the oxygen. Suppose same potassium chlorate on heating, but no catalyst. In that case, it gets converted to potassium chloride with potassium perchlorate. See, potassium chlorate on heating in presence of catalyst liberate the oxygen gas. Same potassium chlorate heating but in absence of catalyst. In absence of catalyst it undergo disproportionation. Here plus 5 to minus 1 and plus 7. Clear? No? So nothing but here Cl ionic if you consider ClO3 minus on heating it get converted into Cl minus with ClO4 minus. Clear, no? Chloride and perchlorate. Mostly this reaction will be takes place in presence of basic medium. If you observe in first PU redox reactions, half reaction method balancing the reactions. In that case, here directly halogens convert into halide and some halide or halide or perhalide like that. Here chlorate also undergo disproportionation to give chloride and perchlorate. Clear, no? Here that chloric acid in which the central chlorine undergo which hybridization and what is the geometry? Here ClO3 minus. Clear? In this ClO3 minus, chlorine is the central atom. Around the central atom, 3 atoms are attached. Group number of central atom 7. Oxidation number of central atom 5. X plus minus 2 into 3 minus 6. X minus 6 equal to minus 1. X equal to plus 5. So divided by 2 will be 3 plus 1 4. It also undergo which hybridization? sp3 hybridization. But sp3 hybridization with 3 bond pairs and 1 lone pair. Therefore, here double bond O, single bond O minus with 1 lone pair is a trigonal pyramidal. Trigonal pyramidal, it is a deviated, not original. Undergo sp3 hybridization, but trigonal pyramidal geometry. Here, only with respect to chlorine, if you consider 1, 2, 3, 3 sigma and 2 pi. Clear, na? Suppose here OH also, if you consider, 1 more sigma will appear. Okay, na? So this is chlorate, is anion of chloric acid. And finally perchlorate. Perchlorate is the anion of perchloric acid. Correct? This perchloric acid is going to prepare when ammonium perchlorate is treated with HNO3 dilute. Ammonium perchlorate when reacts with dilute HNO3 will give us HClO4 with ammonium nitrate. Clear, na? Like this HClO4 is going to prepare when ammonium perchlorate reacts with dilute HNO3 to give perchloric acid with ammonium nitrate. Or some barium perchlorate if you take BaClO4 taken 5 with concentrated sulfuric acid. Concentrated sulfuric acid convert into 2 moles of HClO4 along with that barium sulfate. Okay, so in this way perchloric acid is prepared. And almost all oxy acids of halogens, suppose the same thing, Cl2O7 on hydrolysis with water, Cl2O7 with water will give us 2 moles of HClO4. Clear, na? Chlorine heptoxide upon hydrolysis with water to give perchloric acid. Thus, Cl2O3 is acid anhydride of perchloric acid. Clear, na? This perchloric acid ionize and gives H plus and ClO4 minus. Again ClO4 minus. What is the hybridization of chlorine? What is the geometry? What are bond pair and what are lone pairs of electrons? Clear? So here around the central atom 4 atoms are attached. Central atom group number is 7. Its oxidation number if you calculate also 7 divided by 2 will be 4 plus 0, 4 bond pair and 0 lone pair will give us total 4 pairs of electrons that undergo sp3 hybridization. No lone pair, therefore original structure. What is the original structure? Original structure will be tetrahedral. This is the original structure of perchlorate, is tetrahedral. One common thing you have to observe, every halogen atom in their respective oxy acids undergo sp3 hybridization commonly. Clear, na? Maybe hypohalous, halous, halic and parhalic. In all of them, the central halogen undergo sp3 hybridization. Clear? But depending on number of bond pair and lone pair, deviation will be takes place. no lone pair, original structure is a tetrahedral. One lone pair, trigonal pyramidal, deviated structure. Two lone pairs in case of hallous acid, here angular. Whereas three lone pairs with one bond pair, linear geometry. Clear na? So in this way, oxyacids of halogens. In them, if we consider same series of oxyacid, nothing but HClO4, HBrO4 and HI4 if you consider, in them as the electronegativity of central non-metal atom increases, the acidic strength increases. See, here HClO4, then HBrO4, then HiO4. What I told, all these are oxyacids of halogens. In them, this is the central nonmetal. It is the central nonmetal. It is the central nonmetal. Here, chlorine electronegativity is more than bromine than iodine. The series is same per halate, per halic acid. So therefore, HClO4 acidic strength is more compared with HBrO4 and HiO4. Clear na? Similarly, suppose HClO3 chloric acid greater acidic than HBrO3 bromic acid greater acidic than iodic acid, HiO3. Acidic strength will be in this way. Suppose the same non-metal, central non-metal is there, like HClO4, HClO3, HClO2, HClO. Clear? Your series is different, but central non-metal in all these oxyacids of chlorine same. Now, if the central non-metal is same, as the oxidation number of this central non-metal increases, acidic strength increases. Here its oxidation number is +7, oxidation number +5, +3, +1. The acidic strength of perchloric acid is more than chloric acid, more than chlorous acid, more than hypochlorous acid. In this way, as the central non-metal oxidation number increases, or else one more also you can consider, as the oxygen ratio to the central non-metal increases. Here oxygen ratio, oxygen is 1 only. Here 1 chlorine, 2 oxygens directly attached to chlorine. Now here 1 chlorine, 3 oxygens attached to chlorine. 1 chlorine, 4 oxygens attached to chlorine. Nothing but as the oxygen ratio to the central non-metal increases, acidic strength also increases. Suppose different non-metals are entered like this, chlorine, bromine, iodine. Different non-metals are entered. In that case, as the central non-metal electronegativity increases, its oxyacid acidic strength is higher. Clear na? So these are oxyacids of halogens. And one more also here you can consider oxidizing power. Suppose here this is there, HClO4 is there. Is it further undergo any oxidation? Already 7 electrons eliminated. Right, from outermost shell only 7 electrons were there. 7 out of 7 went out. Therefore it further could not undergo any oxidation. Therefore its oxidizing capacity almost nil. And its oxidizing capacity is higher. That ClO minus greater oxidizing capacity than ClO2 minus than ClO3 minus than ClO4 minus. Clear? So regarding this applicative question, if any comes in this way, you have to keep on applying. So this is oxyacids of 17th group elements. And final subconcept is there, interhalogen compounds. Interhalogen compounds. Interhalogen compounds within them. Suppose X is one of the halogen atom and X dash is another halogen atom. X is one of the halogen atom, other is X dash. X when reacts with X dash to give X dash or X dash 3 or X dash 5 and X dash 7. Total, these 4 kinds of interhalogen compounds are available. Correct? here these are interhalogen compounds. Why the interhalogen compounds are forming? This X is one of the halogen atom, X dash is other halogen atom. These two are different. When these two are different, definitely their electronegativity differ will be there, right? This is left side in any compound, whatever atom is there is lower electronegative atom, right side higher electronegative atom. Generally electronegativity highest possible by smaller atom. Clear? Then lowest electronegativity generally bigger in size. Nothing but X is bigger in size, X dash is smaller in size. When bigger halogen, suppose here, when chlorine reacts with the fluorine, chlorine reacts with the fluorine to give ClF, but FCl not possible. Clear? Na? ClF is right, but FCl not possible. That's what I told. I am telling here X is bigger in size, then X dash is smaller in size. Smaller size always higher electronegative, bigger size always smaller electronegative. Thus, interhalogen compounds, when chlorine reacts with fluorine to give here ClF in equimolar ratio, or when bromine reacts with the fluorine convert into BrF, and iodine reacts with the fluorine to give IF. Clear? Na? Similarly, here when bromine reacts with the chlorine to give BrCl, iodine reacts with the chlorine to give ICl, and finally here iodine reacts with the bromine to give iodobromide. Clear? Na? Here in equimolar ratio, when interhalogens are react like this, nothing but lower electronegativity with bigger size, higher electronegativity with smaller size. All left side whatever I shown will be X, right side whatever I shown X dash. Clear? Na? Here monohalides possible by Hall. Come to the trihalides. If you see here, chlorine reacts with the fluorine to give 2ClF3. In that case, 3 moles of fluorine, excess. Clear? Na? Chlorine reacts with fluorine to give 2ClF3. Bromine also reacts with the fluorine to give 2BrF3. And iodine reacts with 3 moles of fluorine to give 2IF3. Means trihalide X dash 3 will be fluorides. If you see the chlorides, iodine reacts with the chlorine to give 2 moles of ICl3. Iodine I am taking. Here bromine reacts with the chlorine also I can take. But BrF3, BrCl3 whatever is there, stability is less. Means size variation. Now iodine reacts with the chlorine to give this one. These are stable form. Technically, if we want to prepare Br2 plus Cl2, 3Cl2 to give 2BrCl3, possibility is there, provision is there, but stability is not much. Clear? Now trihalides in this way. Suppose pentahalides if you want to prepare. Here, this is one more kind. Penta, that is iodine you can take comfortably, or else Cl2 when reacts with 3F2 gives 2ClF3 covered, then the 2ClF3 interhalide coming forward to one more fluorine, it gets converted into 2 moles of ClF5. Thus here 2 moles of fluorine should come forward. Correct? Here this is a trihalide, nothing but a lower internal trihalide when reacts with other higher electronegative halogen to give the respective higher internal halide. Instead of getting Cl2 plus 5F2, Cl2 plus 5F2 to give 2ClF5, possibility is there, but definitely it should forward through ClF3. Clear? When the ClF3 initial step is formed, that ClF3 further reacts with excess of fluorine to give ClF5. Coming to hepta, iodine when reacts with 7F2 get converted into 2 moles of IF7 around 523 to 573 Kelvin temperature. At higher temperature, iodine when reacts with fluorine to give iodine heptafluoride. Clear? Whatever I wrote, these are quite possible. Other halides, suppose why not here Cl2 reacts with 7F2 to give ClF7. Cl2 size compared with iodine is less. As the size variation between X and X dash increases, the stability of the formation of interhalide will be more. One more time remember, higher the size of X and smaller the size of X dash, readily internal halide is able to form. Clear? So here X and X dash ratio, that is the radii of X, radii of X to radii of X dash value increases, ability of forming stable internal halide increases, and we can find more number of halogen atoms in that compound. Suppose for example, here this X iodine if you take, size is big, and this X dash fluorine if I take, now bigger size to smaller size ratio will become higher value, no? This higher value as the ratio of radii of X to the radii of X dash increases, more number of atoms in that internal halide we will find. Clear? No? In that case, IF7 is more stable. Clear? These are internal halides. And again, according to Vesper theory, internal halides, the geometry, hybridization, number of lone pairs, number of bond pairs. Suppose XX dash, in this form let us consider. XX dash, it is the central atom. Again same, to find the total number of pairs of electrons, around the central atom only one atom is attached. Group number of central atom 7, oxidation number 1 divided by 2. Clear? So that here 1 plus 3 now, 7 minus 1, 6 by 2 is 3. Total number of pairs of electrons are 4. Same sp3 hybridization with 1 bond pair and 3 lone pairs. Geometry is linear, it is not original, is a deviated structure. That is XX dash. Similarly, XX dash 3 if you consider, around the central atom 3 atoms are attached. Group number of central atom is 7. Oxidation number of central atom 3 divided by 2 will be 3 plus 2. 3 plus 2, 3 bond pair with 2 lone pair. So total pairs of electrons are 5. Undergo sp3 dehybridization. In this sp3 dehybridization, here the shape is distorted, T shape. Actually, trigonal bipyramidal. In this, if it is the central X, now it is X dash, lone pair, X dash. It will be in T shape like this. Clear? No? X dash 3. Now X dash 5 if you consider, 5 plus 7 minus 5 by 2 will be 5 plus 1, total 6. sp3 d2 hybridization. Now in which 5 bond pair and 1 lone pair, total pairs of electrons are 6. sp3 d2 hybridization. sp3 d2 hybridization will be actually octahedral. In that octahedral, one of it is the lone pair, one is lone pair and remaining all are bond pair. So depending on these bond pairs of electrons, it is square pyramidal. And finally X dash 7, in which 7 plus 7 minus 7 by 2 now, around the central atom 7 atoms are attached. Group number of this central halogen atom 7 and its oxidation number also 7. 7 minus 7 by 2 will be 7 plus 0. Total number of pairs of electrons are 7, in which it undergo sp3d3 hybridization. 7 out of 7 are bond pair, no lone pair. Therefore, original structure is pentagonal bipyramidal, 5 gonals, central X, and all these planar X dash, X dash, X dash, X dash, X dash. One is above the plane, other is below the plane. Clear? Now here, whatever through pyramids are there, see, here the bond angle is 180. Internal the bond angle is 360 by 5 are there. Clear? Na? So therefore 360 by 5. 72. Clear? Na? 72 bond angle is this, 180 bond angle is this, and to the planar, these 5 are on plane. Pyramid is there. Pyramid to plane 90 degrees again. This pyramid to plane 90 degrees, pyramid to pyramid 180 degrees. Internal one halide to other x dash to x dash, this angle is 72 degrees. Clear now? These internal halides except CLF remaining at room temperature are existing in liquid and solid state. CLF1 exists at gaseous state, and these are highly soluble in water. Internal halides are highly soluble in water. Here internal halides reactivity is more than individual halogen atoms. Only fluorine is different. Fluorine is more reactive than internal halides and other halogens also. But whereas except fluorine, remaining internal halides are higher in reactive than individual halogens. Clear na? Every internal halide undergo hydrolysis with water to give the respective what they are going to give. Unnecessary, no confuse at all. Here x dash, if I consider, observe carefully, x dash, when we keep in water is like this, H plus and OH minus. Now if you come here, it will be plus and minus. This minus go with H plus, nothing but will give HX. With this plus accept OH minus, that is XOH. Or this XOH you can also write as HXO. HXO. Here this is X dash, H plus go with X dash. Nothing but halic acid. This is hydrogen halide is there, see, hydrochloric acid, hydrohalic acid. Halic acid in which halogen is with smaller size. Then oxy acid, halogen is with bigger size. Clear? No? Here X is bigger in atomic size. X is bigger in atomic size. Then the hypohalous acid, in which halogen comes from internal halide, bigger in size. Smaller in size, go with H plus. Suppose if it is XX-3 internal trihalide is there. In that case, same you keep in water. If you keep in water, what will get? This X takes OH minus. This X minus takes H plus. Therefore, here how many are required? 3. Here H plus and OH minus. This X goes with this one. And H plus takes X dash. Therefore, what will get? 3 moles of HX dash. Correct? 3 moles of HX dash with XOH taken thrice. XOH taken thrice lose water molecule. Lose water molecule to give HXO2 na? Observe carefully. X is 1. 3 hydrogens are there. 2 hydrogens went as water. 1 hydrogen left. Now 3 oxygens are there. 1 oxygen went as water. Therefore 2 oxygens left. Then HXO2 na? HXO2 is what? Halous acid. So now from internal halide, whatever the central atom is there, here also it exists in oxy acid as the central atom, but not HX-O2. Clear na? Internal halide X dash could not enter into oxy acid. X only will enter into oxyacid. Clear? Similarly, X5 dash is there. This also you keep in water. What will get? One is definitely HX dash. From this, X dash is smaller in size, higher in electronegativity. Go with H plus from water. This one, that OH will be managed this one. And what it is going to yield? HXO3. HXO3. So total here, how many number of water molecules are making use? If you want 5 water molecules, you can. That's 5 HX. And XOH taken 5. XOH taken 5 lose 2 water molecules. Suppose the same thing, this general I wrote, X dash 5 takes 5 HOH, convert into 5 moles of HX with here XOH taken 5. But XOH taken 5 lose 2 moles of water. Correct? 2 moles of water. Nothing but 5 hydrogens. In that 4 hydrogens as water eliminated. The 5 oxygens, 2 oxygens went as water. Therefore, how many oxygens left? 3. Now 3 oxygens. How many hydrogens left? 1. This. Therefore, resulting, instead of making use of this 5H2O, 5 minus 2, 3H2Os we have to make use. Whenever we will use 3H2O, now here total 5 HX, along with that one HXO3 balancing. Follow down. Here 3 moles of H2O, 3 to the 6 hydrogens. In them 5 HX dash, 5 hydrogens, 1 HXO3. Balance up. So like this, XX dash will hydrolyze with water to give HX dash with HXO3. HXO3 is halic acid. Suppose here this is fluorine, it is fluorine. ClF5 will give out 5 HF with 1 HClO3 chloric acid. Clear? No? So in that way, similarly X dash 7 if you take, then X dash go with a halic acid, this one, and here whatever the perchloric acid we are going to get HXO4, that is XO4, X will come, here X dash will come. Clear? No? So in this way, whenever interhalogen compounds hydrolyze with water, highly soluble in water, readily undergo hydrolysis, because compared with the halogens, interhalogen compounds are more reactive. Right? Readily undergo hydrolysis with water to give their respective oxyacids of halogen. That halogen compulsory must be central halogen will come. Clear? So these are 17th group elements according to your NCERT. And one more concept in case of oxyacids, multiple bonds wherever coming, which kind of overlapping is taking place? Clear? No? So that one more concept let us see. In applicative part they may ask by taking perhalic acid. I will explain. Perhalic acid is HXO4. Correct? HXO4 will be XO3OH. Let me write HXO4. This is OH is one of the group, and the remaining 3 options are groups. Just now we covered it undergo sp3 hybridization, 4 bond pairs, 0 lone pair. Therefore, X as the central atom, here double bond O, double bond O, double bond O, OH. This is the structure. In this structure, here 3 pi bonds and here one of the oxygen around this will be through single bond. Clear? No? So total number of sigma bonds if they ask, this is 1 sigma, second sigma, third sigma, fourth and fifth. So comfortably you can write 4 sigma sp3p. Correct? Oxygen p orbital, this oxygen p orbital, oxygen p orbital, oxygen p orbital. This X is sp3. So 4 sigma sp3p and 1 sigma, this is what? P. It is S. Therefore 1 sigma S and P. Sigma bonds are covered. And 3 pi bonds. 3 pi bonds are these 3. Right? In case of halogen atom here, halogen whatever it may be, noble gas configuration with NS2 NP5. Correct? Noble gas configuration with NS2 NP5. Except fluorine, here N-1D is also available, but it is 0. Correct? At ground state, NS2 NP5 N-1 D0 except fluorine. Fluorine anyhow, oxy acids with higher oxidation number not possible. So that here other than fluorine, if X equal to Cl, Br and I considered, X equal to Cl, Br and I considered, in that case here S2 then NP5 N-1D. Now here this is the electronic configuration. Correct? Now at the ground state, here first lone pair, second lone pair, third lone pair. 3 lone pairs of electrons are there. Correct? 3 lone pairs with one unpaired electron. Here in every oxy acid of halogen undergo which hybridization? sp3 hybridization. sp3 hybridization only na? sp3 hybridization. In case of perhalic acid, compulsory it should enter into third excitation state. Nothing but this electron jump here, this electron jump here, and this electron should go here. In that case, at the third excitation state, third nothing but 3 lone pairs from ground level should enter into N-1D after splitting. So therefore, its configuration will become as only S1, P3 and D3, dxy1, dyz1, dzx1. Here, this S and P orbitals are all involved in hybridization. One S orbital and 3 P orbitals belong to same energy level of this excited, third excited halogen atom merged together to give 4 hybrid orbitals. Now total 4 sp3 hybrid orbitals are there. And in excited N-1, D is having dxy1, dyz1, dzx1. Here 4 sp3 hybrid orbitals, 4 out of 4 are having unpaired electrons. 4 out of 4 are having unpaired electrons. Actually, that X hybrid orbitals, if you consider sp3, second sp3, third sp3 and fourth sp3. Now, third excited halogen only I am considering sp3 hybrid orbitals. All of them are having unpaired electrons. All of them are having unpaired electrons. With this unpaired electron, oxy is an unpaired electron containing px linearly overlap. This is one. And next oxygen having unpaired electron in py. Then pz is unpaired electron, pz. Then px also there in case of oxygen, but lone pair. I am not considering. Now here also this oxygen, clear na? Here one more, this oxygen unpaired electron is linearly overlapped with the hydrogen s orbital. Here this oxygen, one more unpaired electron containing pz orbital, linearly overlapping s orbital having unpaired electron. Similarly here also oxygen py with unpaired electron linearly overlap. Now here pz with unpaired electron as unpaired electron only. Now every oxygen is these 3 oxygen atoms from pz orbital contributing 1 unpaired electron each. This sp3 hybrid halogen in perhalic acid having 3 unpaired electrons in d orbital. Now every d orbital double dumbbell. Here double dumbbell drawing is complex. Therefore drawing is difficult showing on this. Just you imagine. Now this unpaired electron containing pz orbital of oxygen like this laterally overlap with dxy having unpaired electron of excited, third excited halogen from perhalic acid. Clear? Similarly here also one more lateral overlapping, and here also one more lateral overlapping. Now 3 pi bonds are there now? 3 pi. 3 pi between whom? D orbital of this halogen atom and p orbital of oxygen atom. Clear now? So 3 pi dp. Here oxyacid case, they are going to ask which among the following exhibiting pi dp overlapping. Like that question they may ask. So what you have to do? Simply the central atom, ground state electronic configuration, and after excitation state, whether the electron enter into n-1 or that is a penultimate d orbital or not. If entered, those are involving laterally or linear. Linearly in what way you can say? Suppose sp3d orbital, sp3d hybridization we got. sp3d. In that case, this unpaired electron containing could not overlap linearly. Only here if unpaired electrons are there, these only overlap laterally. But linear, this enter into linear only, lateral overlapping, not possible. Who is involved in hybridization? Already you know, every hybrid orbital never involved in pi bond, only sigma bond. Clear now? So like this applicative question they may ask. With this 17th group elements, complete theoretical explanation we covered. And next class on 17th group MTG material entrance discussion will go. Here only the questions I will display, and every question wherever explanation is needed on board, so simultaneously I will explain. And coming Sunday you have weekend Sunday test. In the Sunday test, NEET section students from chemistry side will get 45 questions. Then JEE section students will get 25 questions. In them 20 are single multiple option, 5 are numerical. And KSET section students will get from chemistry side 15 questions. Clear na? So PCMB KSET 15 into 4 60 questions, whereas JEE 25 each from physics, chemistry and maths. Therefore 75 questions. NEET section students physics, chemistry, botany, zoology. Total 4 subjects, 4 into 45, 180 questions. Clear na? So that examination time and everything they will announce shortly. And now onwards, no recorded videos, direct live classes will be there to you. Yesterday actually, in order to perform best, yesterday we made a trial, but in the trial some technical problem arose. That's why majority of the students could not able to follow that. Immediately we got information, and today onwards again online classes only we are conducting. Almost time to time, 3 to 4 minutes difference, time to time according to what time we send to you, like that only classes are going to continue. Therefore follow properly, listen carefully, and keep your material and all, read properly and perform in examination finely. Okay.